So welcome everyone. So today's topic, we'll talk about how to use text to make sense of the data we collected. And there could be a lot of use cases for this. I mean, what we saw with our current customers and using text information for warranty analysis, using text information on where to direct support, or some innovative ways that you may think of using text, basically taking words into numbers in a way to build models. And as probably you're familiar with it so far, in JMP, there are a whole bunch of different analysis tools depending on what you're trying to model and understand. And the FIT model is the regression platform. And then you have access to a lot of predictive modeling tools and specialized modeling tools. Of course, all these require some numbers or categorical values for you to build a model. So today's topic, we'll talk about how to take the text and then convert it to numbers so we can use it for modeling purposes. And what I plan on doing today is talk about the concept first, why and what of text analysis, and we'll talk about what are the kind of things that we should be familiar with, and we'll start with the platform review, and then we'll do a case study. Now, 2 different case studies depending on how much time we have, and we'll see how much we can cover, but we'll share this journal with you too, so you can do your analysis and continue later on. Let's start with the what and why of text analysis. And what we're trying to do is, like I said earlier, we want to turn text into a set of values to conduct analysis and use it for predictive purposes later. And when we're talking about text, compared to numbers, there are different things that we need to be aware of. Those are, what is a corpus? And what we all know what the sentences are, phrases are, words are, but we'll talk about what tokenizing means, stemming, what are stop words, and then we'll finish up with the document term matrix, which will be the numbers that we'll use for building models. And the text analysis platform looks like, I'll just turn this on, I'll turn off the poll, and it looks like a lot of people are using JMP 17 mostly, and then there's 16 and 15 versions. And if there's something that shows up as we go through the presentation that JMP 17 only, I will mention that as well. So first of all, what the Text Explorer platform looks like. And when you open up the dialog box, of course, since you're familiar with JMP, we have a response column. In this case, we have to put all our text columns into our role. And if you're using JMP Pro and you want to validate whatever the solutions you come up with, and we'll put our validation column. But most of the work is done in this part of the dialog box. This is a way for us to impart our knowledge into the platform so we can get the right type of analysis. And the first thing is, since we're talking about text, is what language that we'll be using. By default, JMP will use English or it will use the language that you have installed JMP to use with. But as you can see on the list, you'll be able to analyze text from English, German, Spanish, French, Italian, Japanese, Chinese, and Korean. So those are all built in. The benefit of this is that as we're working with multinational companies, they're multi-language documents, so we can combine them all into one big corpus. And corpus meaning that all the knowledge that we include in this data table. So you'll be able to combine different languages or build models in different languages and able to apply the results to your model building case. The second thing to look at is the maximum words per phrase. If you've done text analysis before, you probably had to specify how many word phrases that you want to use. 2-word phrases, 3-word phrases, 4-word phrases. And JMP facilitates that by answering, you can facilitate with JMP by answering the maximum words per phrase. And of course, as your number of rows of information grow, since JMP has no limitation, you may want to limit maximum number of phrases that you want to use in your analysis. Because this can get out of control real fast, but by default, it's set to 5,000 and you can change it to whatever that you would like. And one of the critical ones here to fill out is that what is the minimum character per word that you want to use? By default, it's set to 1, but in most of the time I use this tool, I set it to minimum characters to be 4 so that I can eliminate words like a's, ands, theys, those type of articles in the language. Although most of those are set up as stop words, meaning that these are the words that we ignore when we're doing analysis. In any case, if there are some few letter words, you may want to exclude that from your analysis. And finally, of course, how many maximum characters per word. By default, it's set to 50. And there are not that many words in the language that we use day to day, more than 50 characters long. And the next thing to answer is that, do we want to use stemming on our analysis? When we talk about stemming means that, do we want to limit our analysis to the root of the words? Like, for example, in our case study, we'll talk about hotel reviews. And in hotel reviews, people talk about room, people talk about rooms. So do we want to include both in the same room and rooms in the same group? Or for example, people are use the words located or location. Do we want to use the word locate as a root word and combine them into same bucket, basically? That's where the stemming comes into play. And of course, by default, it's set to be no stemming, but you can use different stemming options as well. And finally, the tokenizing, by default, it's set to regular expression tokenizing, but we'll talk about this in a second. When we're talking about tokenizing, what we're saying is that every word corresponds to a token. Like if we were to stem it, location, located, locates, and all those words will be represented by the same token of locate. So it kind of like codifying language to some tokens that we can use for further analysis in the future. You can customize this regular expressions. We'll talk about this as we collect the data in a second, but just leave it as it is. By default, it's unchecked. And what we'll do is we'll put our text column. In my data set, I'll put my negative reviews as my text column. Or of course, maybe we want to be more positive, optimistic. Let's put the positive reviews in our text column, and then we'll say, okay. And we'll get a list of all the terms and all the phrases. But at this point, it might be a good idea to actually look into a data table, see what that looks like before we go into analysis. Let me open that data table. And you can see here, these are hotel reviews, the location of the hotel, review date, average score, and some text in the data set. And then total word count, number of reviews, positive reviews, word count, and the reviewer score, date since review, location, and the validation column or not. If we're not using Text Explorer type of platform, most of our analysis will be limited if a certain word occurs or not. And that, of course, predicates that we know about that word in advance. Or you may be using how many words exist in this particular review. Again, by itself, it doesn't really mean much in a word to make sense of the numbers to use for model building. So now we know about our data table and we run our Text Explorer platform. And by the way, to get to that, we want to analyze Text Explorer. It'll take us back to the dialog box that we were in just a minute ago. So Text Explorer platform will give me a list of number of terms, meaning that how many individual words that show up in the full corpus, meaning that all these 996 rows of data that I have, that means my full corpus of these positive reviews. There are a total of 1,766 terms, 996 cases is my number of rows, and there's 16,289 individual tokens. I mean, at this point, you may have heard all this ChatGPT and how many tokens you have is going to drive your results and how much it costs and things like that. So this total tokens refer to how many individual terms and phrases exist in this corpus that I just built. And tokens per case, and it looks like all my reviews are not empty. 99.9% of my data table is full. And very first thing we get is, looks like location shows up the most in the positive reviews, and the staff and the hotel and room and good. And of course, these are the phrases. So one good thing one very helpful thing that I found using Text Explorer in JMP is I don't have to specify how many words per phrase that I need. I can do, by default, JMP will select, since I said maximum 4 words per phrase, all two-word phrases, 4-word phrases, 3-word phrases, and put them into a list for me as, count of each of those phrases. And I can see them as a table. And of course, I can sort them alphabetically, but in that case, it's not going to help me. More important is how many times they show up. Another way of seeing this, if you go to this red triangle under display options, you can show the word cloud. And the word cloud, by default, it's going to select the first word that shows up the most, in this case, location. But of course, you can customize it by going to red triangle, turn your layout. Most people like to see that centered, meaning that most words show up as in the middle of the word cloud, and then the ones that use less show up as smaller words in the word cloud. And of course, you can color this by going to red triangle, color this, let's do an arbitrary color by now, but of course, you can color it by the column values you're interested. In this case, it could be the reviews if you wanted to, the score if you wanted to. So let's do arbitrary color so it looks like it's interesting. Now, take a minute here and look at this. Yeah, I see the words location. I see the word staff. The location itself doesn't really mean much in this context. It could be a bad location. It could be a good location. It could be a scary location. It could be a dark location. So whatever that might be, location itself doesn't really tell me much. But the phrase is great location and good location and friendly staff tells me more than just the staff itself. So what I can do in that case, I'll just select a few of these, but of course you can use Control A and select all. I'll right click and add phrase to my list of terms. And if I do that, then we'll go back and check the word cloud in a second. Add phrase. Now I can see my word cloud is updated. So now I have hotel, staff, location still there, but you will see there's a good location showed up here as well. And when we're doing this analysis, of course, your subject matter expertise come into play. And I'm looking at hotel reviews, the word hotel keeps showing up. And it doesn't really tell me much. I can add that as a stop word, meaning that this is a word you can ignore for analysis purposes. I can either do that by selecting the word hotel on the table and then make it a stop word. Or if you're a more visual person, you can select it in the word cloud and then make it a stop word. So it will remove that from the list. And in this case, I also want to, let's say, remove room. I'm talking about hotels. Okay, room kind of makes sense. It will show up most reviews. It doesn't really tell me much. I'll make that a stop word. Now I have a cleaner version of my reviews. So this kind of gives me a very first quick look to my data table. Now, most of you are JMP users, and you all know JMP is a very interactive tool. It gives me a way to explore data in interactive fashion very fast and quickly and get the information that I need. And as we saw in our data table, different hotels in different countries. Wouldn't that be nice if there was a way to quickly look at these word cloud by country? And I can do that as well. If I go to this red triangle, turn on my local data filter, and I want to filter this by the country. And let's close up our term list. Here's my word location. What does this look like for Austria? Looks like breakfast is important and location is important. How about France? Location is most important. Italy. So I can just go through this. Italy is more spread out. Netherlands, staff is important, clean, nice and great. Spain, again, the same. United Kingdom, it's more like staff and location. So it gives me a quick view. Think about this as if you're working in a manufacturing environment, you're looking at the warranty claims or some user comments coming up and your different part numbers. This will be very easy. It will be very quick way to look at and identify the things that are more valuable to you than going through analysis and trying to figure out how many words this particular word showed up or not. So that kind of makes it easy. So at this point, I'm going to clear this up. But of course, for future use, you can go to red triangle, save the script back to your data table, or add in a workflow. This could be your one-stop shop to get most information very quickly out of the text that you've collected. So what else can we do in this platform? There's a lot more built in. And like every other platform in JMP, you'll find them under red triangle. I mean, we looked at the display options where we turn on the word cloud. Of course, you can look at the stop words that are used. If you do recodes, you can do all that. And we looked at our term options. For our initial case, we didn't use any stemming, but of course, you can go back and change your options as well. So there are a few other things, depending on what version of JMP you have. If you have JMP Pro, you have access to latent class analysis, semantic analysis, and discriminant analysis. These are ways for JMP Pro, in this case, to identify underlying topics in the data set that you have collected. So if there are, like, for example, it'll give you a list of all the words and phrases that relates to very pleasant experience, it relates to room, relates to the shower, whatever that might be. So JMP will be able to read through and understand, get some context, get some topics analysis for that. I'm not going to talk about these because those are JMP Pro options, and not a lot of people have access to it, and we're kind of limited in time. But if you have any questions, please let us know. We'll talk more about that. But what's one very helpful tool here is a sentiment analysis. I'll turn it on. This tool is built in, sentiment analysis. So basically, for each row of information that I collected, JMP will put together a sentiment score, if there's a positive score or negative score. And it will also give you a list of what words contribute to that particular row of observation to be positive or negative. So you can see each of those scores. And of course, it provides a preview of what's in that particular row and how each of these words are contributing to positivity or negativity of these reviews, this kind of text that we're reading. We have these words built in, and these are driven by the dictionary. But of course, you may have a particular need, a particular word that is a function of your industry. You can assign different scores for that. So JMP will calculate individual sentiment that's relevant to your business. By default, it uses a dictionary sentiment term. So that's available. And of course, once you build your sentiment, if you go to a triangle, you can save this back to your data table. In your document, you have some sentiment scores. And if you want to build a model of that, you can do that. Or you can use a column to scale these sentiments. So I mentioned by default, it uses the dictionary values of sentiments. But let's say I want to scale these sentiment values. I'll go to a triangle and go to score column, select my score column, and it will ask me what the rating column is. And I'll select, let's say, the average score, and then say, okay. And all these values will be scored. My overall score that corresponds to average score. So those are built-in tools you can use. Another helpful tool built in, and by the way, this is, I believe, is in basic JMP. Another built-in tool is, if you go to red triangle, term selection. What term selection will do is, so it will ask me, what is my response column? So let's select my average score, right? Let's make this a little bigger so we can get all the information. And so I have a visual representation of what the average score looks like in my data set. And JMP uses some default models. It uses elastic generalized regression to identify that. And then once I say run, what will happen is it will go through and build a model for me for each of these documents. And of course, in this case, it doesn't really tell me much, but it will build a model for me. And I can use that model to make predictions in the future if I want to, like if I get a new review and I want to use it in a model, I can use it to what the expected average score will be. I mean, think of these, since, I mean, this is a JMP Pro feature. When you build a model in JMP Pro, you can save the code that creates it in Python or C or JavaScript, whatever that might be. Think of this, deploying this model as the user typing their comment or wherever the text is coming from. It will automatically calculate the score for you, and then you can decide what to do with those answers. So think about it that way, and I will do this with negative review so we can see what the model looks like. And like everything else, once you have a model, we can go to red triangle, open this model up. Here's my model comparison, how the model is built. Or I can, if I wanted to use the results later on, I can save my columns, build a profiler. So this is all built in. You don't really have to do anything about it. So that's kind of like a quick overview of what the report looks like, what we can do with the results. So I'll take this, since we use this as an example, let's take that and apply this everything that we did for the negative reviews. I'll close this up, go to Analyze, Text Explorer. I will recall what I did, so remember what I selected before, but I'm going to replace my positive review with, let's say, negative reviews. And I'll use my validation column to make sure that everything I select will be validated. And OK. Again, my words and phrases. And I'll do the same thing again, but I'm going to select all the phrases by using Control-A. Right-click, add these phrases. So we'll scroll through, see if any of the phrases showed up, but they will all be listed on my terms and phrases list. And I'll go to red triangle, go to term selection, and select my average score. Here's my average score. And I'm not going to change anything else, but if you want to, you can change maximum term count. By default, it's set, it's looking at the data from that, identifying what maximum term count, but you can say, I want to build a model only uses top 10 terms, top 20 terms, whatever that might be. For the weighting, it uses options like binary, ternary frequency, log frequency, and index document matrix. Just for practicality purposes, you can use any of these for exploratory purposes. But if you want to build a predictive model, my choice would be the binary models, because since I can't know the full corpus in advance, the rest of these things will not really be helpful. So I will stay with the binary and then say run. Now I built a model, and you can see as the model, if you build multiple models, you'll see all of them are listed and see which one is better model than the other. So each of those documents, my predicted versus actual. So in this case, my predicted 8.411, actual was actually 8.4. So it's doing a pretty good job, but in this case, is somewhere something is going wrong. It's probably because there's not really enough information. So it's doing a pretty good job as a model. And like I said, this is a JMP Pro feature. It's very helpful. It's built in. You can use it within one click. But what if you want to, maybe you're not comfortable with using generalized regression and you're not familiar with it. Maybe you want to build different type of model. Maybe you want to build a tree-based model. Maybe you want to build neural networks. So you have different ways of approaching it. In that case, what I would do is I'll go to red triangle and I'll go save my document term matrix. If I click on that, it's going to ask me, how many terms do I want to build a model from? In this case, the algorithm identified there are 118 terms, or the maximum number of terms will be helpful. And minimum of term frequency means that what is the minimum number of times that this term should show up to be important to my model. I'll leave that one as it is, but for a maximum number of terms, let's just keep it as at this point 25, because since we're doing this for demonstration purposes, and like I said about the weighting, if I want to build a model, I'll stick with the binary and then say OK, and go back to my data table. Now you see I have a whole bunch of new columns that tells me if these particular words exist in that document or not. Now I can, since these are numeric columns, they're all grouped together by terms binary. By the way, if you go to edit, search and replace, you can get rid of these binary space binary terms, and you'll just have the negative you'll just have the column names as they are. But for not to save time, let's go to analyze fit model. I mentioned this is so I have access to using these terms as input into my fit model platform. But what I want to show you is, you may not be familiar with it, is a screening tool. Take my screening, turn predictor screening. I'll put my response to be my average score. I'll put all the terms as my possible factors into the response, and then say okay. And now I get a list of all the words that algorithm identified that will be relevant to if I want to build a model for the average score. So rooms are important. The word negative is important. If somebody uses the word nothing, that's important. Really, hotel. So you can see all the words that show up important as building a model. And then you can decide I'm going to use top 10 to feed into the model as my predictive model. And that's beyond the scope of today's presentation. But if you know we have a need to build models like that, please do let us know. We'll work with you. And of course, this also tells me that I probably need to use stemming for the words. So room and rooms will not show up as different ones, as special ones. I probably also want to work through my data set to remove words like also, didn't as stop words. So I will have a more representative way of presenting data. And one more thing, but I'm going to close this up. There's a lot of talk about the ChatGPT and machines understanding language and things like that. And if you start digging through that, they talk about word embeddings. And we have the tool built, not a particular tool, of course, but similar tool built in JMP. If you go to analyze multivariate methods, this is a JMP 17 feature. If you haven't used it, if you can't find it on your version of JMP, that's probably because you have an older version. And there's an option for multivariate embedding. Again, it takes in numeric columns. I'll put my columns, and you have options to do different types of embedding. And let's just see for now, let's do SNE embedding, and then say, okay. What this will do is it will look at all these words. It might take a minute or two to come up with the results. But in the most trivial way of interpreting these results is that I'm looking at edge cases. So you see there's like two different groupings, and there's some edge cases. If I select these particular cases, go to my rows and select my row editor. Where did it go? Row editor. And then let's go to my next selected, which is, I assume, yeah, this is this one. So on those groups of reviews I selected, they talked about nothing to say is excellent. Let's go to the next one. Again, nothing. We built this from the negative reviews. They use the word nothing, nothing, nothing. So it kind of groups those reviews for me in the clusters, so I can decide like what's special about these reviews, or what's special about these reviews, what's special about those reviews. I mean, think of these as, there are a lot of use cases I can think of as one is just like which one's coming from automated system, which ones are genuine type of reviews. You can use these embeddings to identify, to use that type of analysis as well.